Okay, well, as Liz said, today we're going to talk a little bit about SSIS. My name is Jason Granite, and you can see that we're going to talk a little bit about what I call weird behaviors. So, as you're working with SSIS, sometimes you're thinking, man, this is going to work. I've got it all logically laid out, and when you go to execute it, sometimes things are just funky and they're just not doing what you'd expect. So we're going to talk a little bit about that today. So I've got a bunch of demos. I've got pretty much a full set here. So I'm going to just do some real quick, intro here at the beginning, and then we'll get started. I've been in IT since the early to mid 2000s, and I've done all kinds of stuff in IT. I mean, I've supported end users with help desk stuff and systems admin work. I've done development for web applications, ETL, SQL development. I've done report analytics work. Right now I currently work as a consultant with Pragmaticworks, and I concentrate in the BI stack on primarily the Microsoft side, so SSIS, SSAS, and SSRS. You can see my Twitter handle there is @JasonGranite. Sometimes I tweet about SQL stuff, but not very often, and you can also find me on LinkedIn. So with that being said, let's go ahead and move forward with what I'd like to talk about with everyone today. So the first topic that we're going to talk about is when using the OLEDB destination, there is an option called fast load, and we have some paradigms that are used in data warehouse loading that utilize a fast load and then maybe a non-fast load destination. So we're going to talk a little bit about that. We're going to talk about sorted data flows in SSIS. So we're going to talk about why you might want to sort that data and then the different ways that you can sort that. We're going to talk about combining data, which is typically our three components of our union all, our merge, and our merge join. We're going to follow up and talk about sorting with GUIDs. So these are the unique identifiers. And we're going to talk a little bit about how sorting those in SQL versus the way that the .NET framework will sort those for us. And then finally, as sort of a culmination of the sorted data flows, the combining of data, and the sorting of GUIDs, we're going to talk about loading, perhaps a sample dimension that has a GUID business key. And we're going to talk about if that's a problem. We're going to see if there are alternative ways that we can handle that and kind of move forward there, because the results may not be exactly as you anticipate. For some of this, I know it'll be a review for the individuals that are intermediate and above on the SSIS side. Definitely there are some slides that I'm going to breeze through and you'll be familiar with, but some of the demos you may not have seen before, or you may not have had the experience to work with before. So it should be interesting, so hold on and stay with me here. We'll definitely show something you may not have seen before. So let me move forward. And we'll start, as I wanted to talk about that OLEDB destination and specifically the fast load option. So when you're using an OLEDB destination, you have a couple of different data access modes. So in the drop-down, you'll see things like table or view, table or view fast load, SQL, command, a couple other options. The one that we're going to focus on, though, is when you choose the fast load option. And the big difference here when using this is it's going to go ahead and attempt to do a bulk insert behind the scenes of all of your data. So when we're talking about loading, say, 100 records, with the fast load option, we're going to try and do one batch of 100 records instead of doing 100 inserts of a single record. So from a performance perspective, it's definitely a good improvement. One of the things that I see as a common data warehouse ETL practice is a diagram similar to what we have on the right-hand side here, where we'll have the sample data coming in from whatever our source is. We may have some additional, so zoom it is something I'm not as familiar with, so you'll have to bear with me here. I'm going to make arrows go in the wrong direction and pointing in the wrong place, so just bear with me as I work with this. So after we've got our source data, We'll probably have things like lookups and merges in here, depending on what exactly you're going to do with the data. But at the end of the flow, you'll typically see something where we'll have an OLEDB destination with fast load set, and then we'll go ahead and we'll have that same destination, but we won't use fast load. We'll just use that table or view mode. And then finally, we'll go ahead and we'll dump records to an error table. So the idea here is that we'll try and batch load those records first. If we can't batch load those records, we'll load those one by one to make sure that we get all of the ones that we can. And then finally, we'll go ahead and dump any of those error records that still failed out to a table for an additional process, whether that's automated or somebody that needs to look through and say, hey, why didn't record 1, 5, and 7, why didn't these load? So this is pretty common. Everywhere that I've been, everybody that I've worked with, this has been a common theme that you can see. There's all kinds of blog posts about it. Everybody, when you kind of talk to people about the ETL for the data warehouse, this is kind of what they say. Oh yeah, bulk load it if you can, do a row by row, and then dump everything else to an error table. So our demo is going to talk about some of the behavior here that you might not expect to see while we're using this particular component. So let me pop out to show you a little bit about the SQL table that we're going to use and the data that I'm using, and then we're going to go ahead and hop right into the actual demo here. So the first thing I want to show here is just my dim color table. It's pretty straightforward. We just have an identity column here. We have our color, and I'm going to go ahead and say that it's not null, and then we have a description here, just so we can have an idea of what that color might be. There's nothing really unusual here. I just have a PK on it as well, so it's pretty standard fare. In a data warehouse, you may have, I would expect to have a lot more columns in your dimension table, but for our demo purposes, this will work fine for us. So the data that I want to load consists of 6 records. So we've got what I'm going to call 5 good records, and then I've got a bad record here where I've got the color set to null. And if you remember on my table, I want to not allow null values. So I would expect this particular record here to be a bad record for us. So just to take a look here, you can see that again I should have 1 bad record that I'm not expecting to load, and then I have these other 5 good records. So now that we have an idea for the data that I'm looking at in the table I'm going into, I will just verify, yep, my color table is in fact empty here. Just to make sure, you're always doing demos and it never fails that you're like, oh, well, that data already was in the table and it's messing with my demo. So let's pop over to our SSIS here, and the first thing I'm going to do is we're going to take a look at this particular data flow where I've got just the fast load component set, and my idea is we're going to insert all of them or we're not going to insert any of them, because with an idea of that bulk load, I would expect to get all the data or not any of the data. So if you look at the properties here, you can see that I do have that fast load option set, and all the rest of the options are set to the defaults. So if I just execute this particular task, we'll see that we should get an error here, right? And it's interesting because in the output down here, you can see that it says, hey, this set destination, it went ahead and it wrote 4 records. Well, I'm not so sure I believe that, because with the idea of this bulk insert, I would expect not to write any records. But let's look at our table just to be sure. So we look at our table, and in fact, we do see that we did not load any records, right? So this worked exactly, in my opinion, as I expected. We have a bulk insert with a bad record. That record is going to cause that entire batch to fail, and we're not going to write any records. So just to give us the alternative side of this, I have the same sort of a flow here, but you can see I do not have that fast load option checked. So we're just going to go ahead, we're going to load that sample data into my dim color table, and we're just going to do it row by row, right? So I just want to illustrate the difference here. So with this, of our 6 records, I would expect 5 of those records to go in, right? So we definitely had an error message here. You can see this failed. And you can see that it says, hey, I wrote 4 of those records. So weird again, right? I would have expected 5 records here. We had told it to insert row by row, right? So let's take a look at the table. Let's see what exactly we had happen. So we look at the table, and you can see that I loaded 4 records. I would have had an error record here and then my last good record. So what happened is I loaded successfully as much as I could into the table until I hit the first error record, and then it bombed out. So I don't get that last good record in here. So I only have 4 records in this particular table. So that's not really the behavior that I want or I anticipate, right? Not really what I was expecting. So let's do something a little different. Let's go ahead and let's use the destination error output, right? Let's redirect our error rows so that if we have any errors in our first destination, we'll just go ahead and we'll try and load those in our second destination. So the idea being we'll go row by row here. If you have any error records, we'll try and pick those up in the next one, right? So if we run this and we execute this particular task, what we should see is when we come in is we'll see that we have a data viewer over here. That's why I did this last time too, and it got me when I was showing the demo. So first data viewer here, I've got those 6 records coming in, right? And then our second data viewer shows that we do have that single record there with the null value. So if I move this a little bit out of the way, you can see that we did have an error here. And down in our output, you can see that we said, hey, we wrote 5 records and then we wrote 0 records. So this sounds more like what I wanted, right? This sounds exactly like what I was looking for. So let's look at our table. And you can see that our table has 5 records in it. So that's good. That's cool. I really want to do those bulk, right? I really want to see those records go in a bulk manner if I can, because it's going to be faster, and then we'll just go ahead and we'll pick up the extras that we can insert, and we'll just do that row by row. So same thing here. I have the first fast destination set, and then I go ahead and I have the row by row after it. So let me truncate my table real quick. Easy enough, and then we'll go ahead and we'll execute this guy. Take a look. And I have some data viewers, but they're doing the same thing we had before. We saw 6 records and we saw a single record. So again, we had 6 come in, we had 1 go to our error, and you can see that this is a little different. Oh, see, I told you Zoom It was going to get me, right? I was going to do something wrong. So the interesting thing here is it says that my fast load, my bulk insert, wrote 5 rows, right? So if you remember when we just had the bulk insert set, that fast load insert set, and I tried to insert the record set without the error redirection, I didn't get any records. But with the introduction of this error redirection here, what I get from this bulk insert is all 5 of those records insert. So behind the scenes, and it doesn't convert to a row by row, it's still doing a bulk insert in this operation. If you were to trace it, it's very interesting, and this is what I would call weird behavior, right? Because previously, and I know that we had seen this behavior before in previous versions of SSIS, I don't know, something definitely has changed. But before, if you would run that fast load insert and you had an error record, you know, a record that it couldn't insert correctly, it wouldn't write any records in the bulk insert, and instead it would move forward and it would write those in the row by row. So it's interesting the way that this behavior changes slightly when you add that error redirect here. So you still get the advantage of writing all of those records at once if they're possible to write, and then you can send those errors to the row by row. So one of the things that this begs the question for me is, well, what happens if I set error to redirect on this, but then I don't do anything with it, right? So I still am going to use the fast load, and I'm going to tell this, if I hover over this, it says, hey, these rows are being sent to the error output, right? So I'm definitely using my error output on this. Does it still bulk insert these for me? So let me reset my table here. So I'm back to square one. And let me go ahead and execute this task here as soon as I go ahead and stop my last running task. And what we're going to see is this completes successfully. We had 6 records there, and if you look, we wrote all 5 of those in a bulk fashion. So the real reason for this demo and why I wanted to call it out is a lot of the assumptions that we've had before when working with that, I'll back up a couple of slides, when working with this setup that you see over on the left here, or on the right here, you had to do the set base operation, then do the row by row, and then redirect everything to the error tables. It's interesting because now it seems like if you can utilize that fast load option, you can still get all of your good records that are loaded bulk. You can get that even with the error redirection. You just have to turn it on, right? You turn that error redirection on, and you still get things loaded bulk. So that second destination using the row by row insert, it's almost unnecessary and isn't needed. So one of the, man, I keep clicking to make my little drawing here. So the one thing I have to say from this is your mileage may vary. So when you're testing with your packages as you're doing your development, always test to make sure that you're getting the right data that you're expecting. You're loading the data as you expect. You're not dropping records. But it's very interesting because this result here indicates to me that you could get away with just using one single output destination and redirecting those errors to your error table. You don't need that second row by row insert. So again, your mileage may vary, and that may differ depending on perhaps an older version of SSIS, because I know that when I've been developing, I've always followed that. And in this case, it doesn't seem like you need to now. So switching gears a little bit, and we'll try and go through this pretty quickly since I know a lot of you do have experience with SSIS. We're talking about sorted data flows. So in SSIS, the flows of data that you have from the source, you can indicate that those are sorted in any particular order, by any number of columns, and you can say whether that column is sorted ascending or descending. The reason why the sorted data is important is there are a number of components that require your data to be sorted. So for example, the merge and the merge join component, and a lot of third-party components, especially if you're talking about data warehouse work, components that will help you to decide whether rows have changed. So when you talk about perhaps like slowly changing dimensions, those types of things, those components that can help you with that also require that data to be sorted. And SSIS knows that this data is sorted because of a special property it has behind the scenes called the sort key position. So if you were to look at that property or you wanted to set it, you can go to the advanced editor, you'll end up on the input and output properties, and then in there you'll see sort key position. So a positive number is an ascending sort and a negative number is a descending sort. So if you had 2 columns that were sorted, say the row number was the first one to be sorted, that would be a 1, and your second column would then have a 2 as its sort key position. You can also see it in the data flow path editor, and it's going to be viewable only there. You can't make any changes there. You can just see in this case that we have our row number here is sorted and our row description is not one of the sorted keys. So talking about sorting, there is a built-in standard component that comes in SSIS that will not only set that sort key property correctly, it'll also go ahead and sort that data for you. This component is one that typically people do shy away from. A lot of individuals, when you talk about performance, this component is not a very high-performing component with large numbers of records. It's also a blocking component where it requires everything, all that data to come into the buffers before it'll start doing any of that work and sorting that data flow. So it's one that typically you avoid. For small record sets, it can be, you can use it and it can be fine. But once you start talking about large data, you're talking about 25,000 plus records, sometimes even less than that, depending on how wide those records are, how much data you have in there. It can definitely be a definite performance hit. So talking about combining data, this goes right along with what we were talking about with the sorted data. And there are a couple of components that are in SSIS that allow us to do that. Those would be the union all, the merge, and the merge join. And I know I'm moving through these pretty quickly. We've got a lot of demos, and the demos are really the more exciting part, in my opinion. So I want to make sure you guys get to those, guys and gals. So the union all, just brief description, right? We've got one or more sorted or unsorted streams of data coming in, and the output is going to be one unsorted stream. So anything coming into this component, regardless of whether it's sorted or not, is going to pop out of the other side unsorted. The merge is slightly similar. It only will take one or two streams of data, but they have to be sorted. It's required that they're sorted going into this component, and the output then is one sorted stream coming out of the component. So here, sorted required in, and it will give us the benefit of sorting that on the way out. And finally, the last component that you can use to put data together and combine it in the streams is merge join. It is also going to require two sorted streams, and it will give you an output of a single sorted stream. The difference with the merge join versus the merge is this merge join allows you to inner join these two streams. You can left join them, you can full outer join them. So you can take some of the columns from the left, some of the columns from the right stream, and put them together to make a new record. With the merge, you're essentially taking every record on the left and unioning that with every record on the right of the streams. So let's do a quick demo here where we're going to talk about sorting and these combining of data flows. For this particular demo, I'm going to use ints on purpose, and we're going to talk about the difference of the sort order when we're using the union all, the merge, and then I'm going to show us trying to trick SSIS to mess around with the way that it's sorted to see if it's going to even let us do that. So let me bring up our, let's see, do I have any T-SQL to go with this? No, I don't have any T-SQL to go with this one, so this one is just the demo here in SSIS. So we have a couple of data flows here. Again, I talked about the union all one, the merge one, and then we're going to go ahead and we're going to mess with SSIS with these last two tasks here. So the first task, and we'll briefly talk about it. We do have a source coming in. I'll take a look at that in a second as soon as I zoom back out. I'm going to conditionally split our records for even and odd. See, I have the arrow going the wrong direction. I told you I'd do that. So that we can have some of those records going through what I've used a script task to simulate a short delay so that I know that all of these even records are going to arrive to this union all after the odd records have. After we've done that, I'm going to go ahead and use a script component just to go ahead and add the row counter to that data flow. And then we're going to go ahead and we're going to take a look at the, whoop, did I zoom out? Yeah. We're going to take a look at the data viewer because I want to see what position that data is all in once we get down here. And if we just take a quick peek at our source data, it's pretty straightforward. We just have the row number, and then we have the row, and I'm going to go ahead and order it by the row number to make sure that we get these coming in for this source component one after another in ascending order. So let's go ahead and let's execute this particular task. Man, time's flying by. I see we're already almost halfway finished. So it always seems like it goes and goes. So we've got, as you can see in our data flow here, right? We split our records 5 and 5. We rejoined those. We added the row counter, and now we're sitting at this data viewer. And unfortunately, I've got to make these columns a little bit bigger for us. But if you look, what you can see is that we have in that the first part of the buffer, right? We have all the odd records, and then we have all the even records. So these records are not in that sorted order after our union all. So we could definitely validate that and verify that we would expect that by clicking on this data flow. We could look at the metadata, and you can see that we dropped the sort key out. So going into that union all, as we said in the slide, even if that data is sorted inbound, it is going to be unsorted coming out of that. So let's take a quick peek at this merge version, which is very similar. It's very similar. The difference being I just have a merge here instead of that union all. And let's see what this one looks like when we execute this one. All right, and so you can see I had my 10 records. I have my 5 going down each of the sides here, and then as soon as my screen refreshes, I bring over my data viewer. You can see that we have all of our, let's see, I wanted to square that one. We have all of our row numbers in order. So our row counters that we had added here for where it is in the buffer matches our row number. So this is still in sorted order, and that's good, right? That's what we expected. We were using this merge component. And again, if we peek at this metadata here, you can see that our row number does include that sort key being set to 1 still. So works out good, right? Still as we expected. Integers coming in a sorted order. They're coming out in that sorted order, even with my delay to make sure that they hit this component, you know, out of order. So that's good. So let's try and mess with SSIS here. And one of the things I did was in this particular component was I wanted to go ahead and, there we are. One of the things I wanted to do was not only just simulate a delay, I wanted to try and be clever, and I wanted to set our row number. I wanted to do a calculation to make sure that I was overwriting that value that SSIS thought it was sorted by. So I wanted to make sure that to see if I could do, mess with that and see if SSIS would know. And in fact, as you probably could guess from the error that is shown here, SSIS did in fact see that was the case. They said, hey, listen, this input 1 here, it's got to be sorted. So you were messing with us, and we saw that, and we need you to resort it, and we need you to go ahead and put a sort there, or take this portion of your script out, because I know that you're messing with a sort order key column, and I'm not going to let you do it. So SSIS knew, right? It knew I was really messing with it. So I thought, well, what about let's just make this the same value, right? Let's just still use that script task, but let's set the row number to the row number. So I'm not really manipulating the data itself. I might be manipulating the column, but I'm not manipulating that data. Interestingly enough, SSIS still says, hey, listen, I saw what you did there, and I'm not going to let you do it. So you can't do that. You can't mess with that sort order column and expect me to think that it's still sorted, right? here it is saying, hey, listen, this has got to be sorted. What are you doing? You can't mess with me like that. So cool, right? So SSIS has said to us, listen, I know you're trying to work with a component that requires sorted information, and I'm going to need you to go ahead and sort that for me. I'm not going to let you work with that data without it being sorted. So that seemed to work well, right? So SSIS kind of saves us from ourselves here, and that's good. That's good, right? So the idea being here, this demo with the integers, everything still sort of works as we expect. All of those sort orders still come out correct. So let's talk about one of the main things here. Let's talk about unique identifiers, right? Because our demo, we used integers to do the sorting. So let's talk briefly about unique identifiers. So unique identifiers are GUIDs, if you're coming from the .NET world, are that globally unique identifier that consists of a string of characters and numerics and dashes and is supposed to be unique, right? So in SQL, you can generate those by utilizing the new ID function, which will just go ahead and pop one out for you. Or if you've got a default constraint on a table, you can go ahead and use new sequential ID, and it'll essentially give you the next one in order so that you can go ahead and, so that gives you the next GUID in order so that it's one after another. The interesting thing to note here is that the sorting is different here. So when .NET, the framework, sorts these globally unique identifiers, it sorts them in a different order than SQL Server does. So it's a known item we're going to see on the next slide where it's talked about, it's documented. There's some good blog posts on it out there. I believe Alberto Ferrari has a good one out there. There's a number of Stack Overflow articles that talk about exactly nuts and bolts why it's different, but the byte order comparison is different between the two, which interestingly enough, if you were to convert this GUID to a character string and you sorted that sorting is obviously also different than what .NET and SQL would have sorted it in. So if you compared the sorting of a .NET unique identifier, SQL sorting that unique identifier, and SQL sorting that unique identifier converted to a string, all three of those sort orders are going to be different. So from the sort transformation page on Books Online on MSDN, you can see there is a blurb here where it calls out and it says, hey, this sort transformation does not sort those GUIDs in the same order as the order by clause. So you have to be careful, right? If you're expecting that data coming through the sort transformation to have that same sort order, it's not going to be the case, and it's going to cause some issues. So I have an interesting demo here where I had loaded 16 million different identifiers and sequential identifiers, and I'm going to run them through a SSIS, just a simple task to sort those and then compare the values between what T-SQL thought they should have been sorted in that order versus what .NET says that it should have sorted those in. So we're moving quick here, so I'm just gonna highlight these. But basically, to set this up, I've got 3 different tables. I have one where I have a default of that new sequential ID. I have another table with a default of just a new ID, and then finally I have a third table where I'm just using some specific GUIDs that I know will trip up the sort order between the two. And then to store those results, I just have 3 tables where I'm going to go ahead and dump the ordered sequential, and I'm gonna have what the SQL row number was and what the .NET row number was. And I'm going to do the same thing for those non-sequential GUIDs and then also those specific ones that I had designated. So this will just allow us to compare between the two. Hey, was the SQL row number the same as the .NET row number? So let's take a look. So I do have, like I said, I loaded records into these tables, and you can see I loaded 16 million records into both the sequential and the non-sequential tables. And just to give you a quick look at what that sequential one might look like, that data looks something like this. So you can see that these GUIDs are from SQL Server in what it feels are ascending order. So let's take a look at the SSIS package that I have here. This one's pretty simple. This one's just a data flow task, and I've got 3 flows in here. Essentially, all 3 of these are going to be the same. I'm going to get the source data. We're going to go ahead and sort it by that unique identifier. We're again going to use a script task, as you saw in a couple of the previous demos, to go ahead and add the row number for it, and then we're just going to go ahead and dump it into that particular table. And then for the source here, again, you have the unique identifier, and then I'm telling SQL, hey, give me the row number, and we're going to order by that unique ID. So this should be the order that T-SQL thinks that they should be in. So I'm not going to run this. This takes, on my machine, it took about 10 or 15 minutes to run because we have sort components in here, and there's a lot of records going into those. Like I said, about 16 million for these first 2 rows, first 2 sets of data here in the flow. So it took a little bit to run. So we don't have time demo-wise to show that, but what I can show is my end results. So in my ordered sequential set, let's look at the count where the SQL row numbers didn't equal the .NET row numbers. And in this case, you can see that I had 16 million of those records where it said, hey, listen, the .NET sorting doesn't equal the SQL sorting. My non-sequential IDs, it just so happens that the ones that were loaded did not, we didn't exhibit this problem on any of those particular records, so that's okay. And then on my records where I did bring those in, where I had some specifically designed GUIDs to trip it up, 32 out of 33 of those did get hit. So let's take a look at the sequentially ordered ones. We'll just look at the top 100. We're going to order by what the .NET row number was here. So we're going to see what it thinks and look at some of these differences. So this first GUID here, .NET thinks this should be the first one. If you sorted all of the GUIDs from this record set, it says, hey man, this one's number 1. Interestingly enough, look at what SQL thinks. SQL said this is actually 4 million, just over 4 million place in that record set. So it's a quarter of the way through the record set for where it thinks that this particular GUID should be. And these numbers, they just they get more and more diverse, right, as we go down, right? Here's one we said, hey, this should be 6. It's 234,000 positions in. So the ordering between .NET and SQL, this definitely will show you that it is not the same, right? It is definitely different. And even my specifically designed GUIDs here that I put together, you can see that this one here where it says, hey, this should be number 2 in the record set. Well, number 2 from T-SQL, it thought it was way down here, right? So it compares, we have 100 in this set here. We have a 1, just a single 1 in this set. So the reason or the how that it's sorting it differently is not the important part that I wanted to talk about here. Like I said, there's a lot of information online that talks specifically about that. The important part here is that it does function differently, right? The T-SQL sorting is definitely different than the .NET sorting is, and that .NET sorting is what you get from the sort component inside of SSIS. So I can see we have about 20 minutes left, so I'm going to head back to the slide deck here, and we're going to keep moving. So where does this lead me, right? So we talked about what feels like a number of different things that are sort of, it seems unrelated, right? So we talked about sorting some data, we talked about the components to sort data, and we talked about how the unique identifiers sort differently, right? So one of the situations that I ran into in a previous life was we had some data loads that were happening for our data warehouse, And one of the portions of that load required us to hit a web service to see and validate that particular record to see if we had a token saved for them. But we had to hit a web service for it. And that web service, I'm not going to say it was slow, right? But it was definitely slower than having to handle any of that memory, any of that data in the buffer in memory as it was running, right? I had to reach out to a web service, let it do its lookups and the logic that it needed, and return me back the answer. So what we found was the key that we were using in this case was a GUID. And you'll see GUIDs, a lot of popular CRMs use GUIDs for all of their entities. So a lot of .NET developers that I've worked with love to use GUIDs for those unique identifiers because they say, man, it's in the name, right? It's a unique identifier. I know I'm going to get a unique one. So I see them a lot of times all over the place. So in our situation, we had a unique identifier as our business key. We were doing something with an external web service that caused that part of the data flow to slow down a little bit, right? To come in out of order back into our union or our merge, whatever we were using. And we found that when we tried to match up those records to do a standard comparison to say, hey, is my data warehouse record, is this new record that I have, is it found in there, is it different? We found that we were throwing away a lot of records that we should have been loading, or we were trying to duplicate load a whole bunch of records because that flow was out of order. So let's talk about I'm going to reach back over. We're going to look at a demo where we're specifically going to see this behavior, and we're going to see some of the weirdness and some of the strangeness between here, and see what we can do. We'll talk about some alternatives to try and get around this, and to see what we can do to fix that. So I see that we do have we got 15 left, so we should be good here. So let's talk briefly. I do have some setup T-SQL first for this one. So our table that we're going to try and load here is just this dim unique ID. It's just got an identity column on it. We're going to go ahead and load our unique business key, which is our GUID identifier value. I just have 2 date times on here for the add date and the edit date, just to be kind of data warehousey, if you will. It's pretty standard. The primary key is that identifier we had. I do have a unique constraint to only allow us one of those BKs into this table. And then you can see that I do have my 2 constraints down here that are handling my 2 date values. So pretty straightforward. Obviously in a data warehouse situation, I would expect to see a number of additional columns here, but for our demo purposes, it works out pretty well. So the source that I'm going to use is we had loaded 16 million of those sequential unique IDs in the table for the previous demo. So I'm actually just going to use 1,000 of those records, and I'm going to order them by their unique ID. So if we were to look at these, they're going to look, very similar to the last shot that I showed. In ascending order, we're essentially going to load these particular identifiers. So let me just make sure that my table doesn't have anything in it right now. Oh, and it does have some data in it, so let me go ahead and reset this to truncate it. And you can see, yep, our table is empty. So let's go ahead and let's step over to SSIS, and let's talk a little bit about this. So these first 2 I'm going to load using the first one. I'm going to use the union all component as the basis, and the other one I'm going to use the merge component. So if we zoom in here a little bit, since I scroll up, okay, you can see this looks very similar to our other demos, right? So I'll take my 1,000 records. I'm going to split those even and odd to go ahead and simulate my delay. So if you remember from my example where I was talking about that web service would be what I'm simulating here. I'm simulating a slight delay in these records. We're then going to go ahead and use our union to rejoin these 2 data flows. I'm going to go ahead and use the sort component to go ahead and sort on that unique ID. And then after we've sorted it, we're going to go ahead. I'm going to add a row counter here for the data flow. We're not going to need that, but it's just sort of a holdover from when I was testing. And then we're going to load that into arrow going the correct direction. We're going to load that into the left side of the merge join. And on the right side of the merge join, we're going to go ahead and grab our data out of our DIM unique ID table. We're going to go ahead and see which of those records were actually loaded. And then in the event that those records were not loaded, we're going to go ahead and load those in. Or we're going to go ahead and say, hey, those are already loaded, and I'm going to send them to a terminator destination. So I'm not going to do anything with them. So data warehouse-wise, this is pretty similar to what you would normally see. So nothing really surprising here. So if we execute this, and my data warehouse table is empty. So I have 1,000 source records to begin with. My data warehouse table is empty. I would expect to see 1,000 records flowing in here. So as soon as we start going, you can see I do have my 1,000 coming in. I'm splitting my 500 both directions. If we scroll down a little bit, you can see I do have my 1,000 coming in. I don't have any coming in from my data warehouse table, and I have all 1,000 loading. So cool, right? It loaded my 1,000 records, so that looks good to me. If I double check on my count for this particular table, hit the right key, you can see I have 1,000 records, so everything there is good, right? So that worked fine. So what happens if I rerun this? So with a data warehouse, right, let's say we ran it for today, we're going to go ahead and rerun it for tomorrow. So let's go ahead and let's execute this same task again, and let's see what the behavior we get is. And we've loaded all 1,000 of those source records, right? So my source records aren't changing. I still have the same 1,000 records coming in. So if we look, 1,000 coming in, we're splitting 500 and 500. Go down into the next piece, you can see I have 1,000 coming in from here, and I have 1,000 coming in from my data warehouse table. Cool, cool. Move down. Well, this is a problem, right? 798 of those records, it seems like it needs to load again, and only 202 of those records already have been loaded, and that's a problem, right? That's not right. That's not what we wanted to see. We wanted to see all 1,000 of those say I've already loaded them, because we have. So let's step back and let's go ahead. We'll truncate this table, right? So we talked earlier about the sorting being different between .NET and SQL, T-SQL. So we had sorted inside of this union all because we had those orders, those records that come in out of order. We had caused a sort here. So this sort definitely made the order for this side of it different than it would have been from T-SQL. So when that merge join came in to join on those unique BKs, they weren't in the same order. So our records that we should have seen as all being loaded were not seen as all being loaded. So no problem, right? Let's go ahead and let's use the merge, because the merge, if you remember, is a component that when used, the output is already sorted, right? So we have sorted input coming in here. We have sorted output coming in here, and we have that output sorted going out of here, right? So I don't need to do a sort here. This merge is already letting me know, hey, my data is going to be sorted. So let's go ahead. That's the only difference here. We're still coming in from our data warehouse, joining with our merge join, splitting records, right? So same setup. Let me just make sure I truncated my table here. And I did, okay. So if we execute this merge statement, we can see that we've got our 1,000 records coming in, 500 and 500, right? It's going to go through our delay. It's going to come into our merge, right? So we have 1,000 coming in. We don't have any in our data warehouse table, and then all 1,000 of those are getting loaded into our warehouse table. Cool. That's good, right? So merge join and union all, both of them work the same on the first run. right? So that's good. That's working for us. So let's go ahead and let's execute this guy again. So now the subsequent second run of this, we already have all 1,000 records in the table. And we'll scroll up, 1,000 records coming in, we split. And here you can see, yep, we loaded 1,000 and 1,000, and 401 of those records it said it needed to load, and 599 of those records were already loaded. Well, it's interesting because when we did this with the sort component, if you recall, there were 798 or so records that it said needed to be loaded. Well, we don't have a sort component here. We're using the merge component, and it says that 401 of those records have already been loaded. So the sort order coming out of the merge is also different than the T-SQL sort order. Because if it was the same, I would expect this to have said, hey, I don't need to load these records. They're already in the table. So the takeaway here, and an interesting tidbit about that, is this merge join, when in regards to unique identifiers, it is not the same. It is not the same as doing a union all and a sort, right? The sort order that we get from this merge component was different than that same sort order that we got when we unioned all these together and then we sorted them. So the implementation of the sort between the merge component and the sort component is even different. So just interesting, it's sort of an interesting tidbit, one that I am going to take a look at because it's interesting to me, but it's interesting to know that if you were to merge these and you had a sort on the other side, your data still wouldn't be in the same order. So to go ahead and correct that, and I had a couple other demos in the middle here, but I definitely I knew I was going to be long-winded and I knew I was going to run short on time. But essentially the demos that I had in the middle were doing the sort directly from the source, where I had both of the sources sorted and I wasn't requiring a sort component in SSIS. And then also when I was converting those sources to a string, and I was doing that as well. So just to take a peek at those, you know, source coming in, data warehouse coming in, just merging those directly, and then the output. This works as expected. This you can run, you know, as many times as you want because T-SQL is performing the sort on both sides. So you know that when that data hits this merge join, it's in the same order from both of these sources. And then similarly, if you were to convert that data to a string, which the only difference I have in here is that I'm casting that as a string and then I'm ordering by it. Same thing. These would be in the same order, so the data will properly load to the warehouse if it isn't there, or it'll say, hey, I've already loaded it. So this one also works as expected. So one of the takeaways from this is how do we take care of this, right? How do we talk about using the unique identifier as our business key and having it work in this situation? You know, what can we do? So one of the simple suggestions that we can do is this same flow, right? I've got the same flow as I had before. The difference is I've added that unique identifier as a string value, and I'm actually sorting based upon that character string value, because SQL and .NET will sort those strings the same, right? So if I have this unique identifier sorted, that will sort the same way from T-SQL as it does through that sort component. So this will work as expected. So let me see what I have. What I have here. Do I have any data in this table? No, I don't have any data in there yet. So let me just run this twice, and I'll illustrate this working as expected. So we'll execute this task. And then I know we have just a couple of minutes. We're button right up there. As soon as I get done with this, we'll talk briefly about some of the other suggestions I have for fixing this sort of a problem. And then we're probably good to go for that. I know it's been an hour of a lot of demos, a lot of talking. So I appreciate everybody hanging in there with me. So this one you can see we had 1,000 records coming in. We had no data warehouse records, and you can see that it successfully loaded those 1,000 records. So if I execute this again, if you remember before when we were doing the sort on the unique identifier itself, we were still trying to erroneously load records. So let's see if this does the same thing when we hop in here. Nope, not done yet. Okay, sorting, perfect. So we look at this, you can see we had our 1,000 records come in from both sides, and this time it successfully said, hey, wait, I already have all of those records in that data warehouse table. We don't need to load it. They've already been loaded. So that works as you would expect and as you kind of wanted it to work. So to follow up, the quick alternatives here, right? If you've got a GUID business key and it's something that you want to use on, in, for example, your data warehouse to compare values and say, hey, do I already have this business key loaded? Alternatives that you can utilize are you can convert that value to a string. You can convert that unique identifier to a string on both sides, and then it'll go ahead and sort properly for you. The other option you can do is you could put sorts on both sides. So if you sort the one side with the sort component using the .NET sorting, you got to sort the other side as well, so that you're sorting apples to apples and those match up. I don't necessarily suggest that. As we talked about, you try and stay away from that sort component, but it is a potential option. And in my opinion, the third, or the most popular option and beneficial for you will be during your staging. So if you're staging this data, you're staging that data with your business key, go ahead and convert that to a string in your staging process, so that in your staging process you don't have to worry about saying, hey, is this going to sort correctly because I'm trying to sort it as a unique identifier. Just convert it to a string there. Or if you have the opportunity, you could go ahead and do a GUID mapping where you could map that GUID to a big int, and then you could utilize that big int as the business key. You can still load that GUID in, but you could utilize, for comparison purposes, big int to big end. So I know that we went really quick here, and I hope that you got something out of it. I know it's sort of some unique niche behavior, but hopefully the next time you're working with unique identifiers and SSIS, you can hopefully save yourself some trouble when you're like, well, why isn't this working like I wanted it to be? So Liz, I know that since we butted up to the end of time, if we had questions and stuff, I could probably do either a follow-up webinar, or I could probably see about posting some blog responses.
Just a couple questions right now if we want to do them real quick.
Yeah.
The one question that a lot of people asked was, which version of SSIS are you using?
So right now I've got Visual Studio 2012 installed, and the version of Data Tools that I have installed I think is 2000. I think it's the January release. I'd have to look at the actual version number. But this behavior, and it could be that newest vNext versions are slightly different for these, but the sorting, the known issue of sorting being different between SSIS and T-SQL is something on the books online that it is shown for SQL Server 2016. So it is definitely still something that happens with SQL Server 2016. So it is definitely still new, and it is not something that has changed, and it's been like that for quite a while. So, and with any of these weird behaviors, right, we pick this stuff up when we say test, test, test. anytime that you're working with these items and you're seeing these sorts of weird behaviors, testing is where we catch this sort of stuff. And they're mostly just gotchas for those.
All right. Well, I think just from looking at everything else, it's pretty much just statements. Oh, well, here's one more that just came in real quick. Why not use a lookup component to determine if a row is loaded versus these merge joins?
You definitely can utilize a lookup component. There isn't any reason why you wouldn't be able to do it that way. Depending on what your data looks like. So let's say that your lookup components requires data from multiple data sources, perhaps, to be put together correctly. You may not be able to utilize that lookup, or you may not get the performance that you're looking for if you've got to use like a linked server inside of that. Just, it depends. But yeah, a lookup component is obviously an option as well if you wanted to utilize that instead of a sorted type component like a merge join or those. So that's also certainly a possibility.
All right. Well, I think that's pretty much all the questions. If you guys happen to think of any questions that you didn't get a chance to put in the questions panel, you can email me, Liz, and I'll be happy to pass them along to Jason. As always, the session was recorded, and you'll receive an email tomorrow with the link. If you need anything else, please feel free to reach out. Jason, thank you again for presenting, and thank you again, everybody, for joining us today.
Thank you.
Thanks, guys.